Welcome to G Fun Facts Online, where we dive deep into the science behind our world. Today, we're heading to the beach. But we're not just building sandcastles. We're exploring the epic, unending battle that shapes every coastline on Earth. That beautiful shore you love to visit? It's a war zone, a dynamic, ever-changing landscape caught in a relentless tug-of-war between destruction and creation. Let's get right into the science of how our coasts are constantly being torn down and built back up. At the heart of it all are two fundamental processes: erosion, which wears the land away, and deposition, which builds it anew. Think of it as nature's ultimate renovation project, driven by the immense energy of the ocean. First, let's look at the demolition crew, the agents of erosion. The main culprit is the sea itself, and it has four primary weapons. The first is hydraulic action. This is the sheer brute force of water smashing against the coastline. During a storm, a single wave can exert immense pressure, forcing air into tiny cracks in the rock. As the wave pulls back, that compressed air expands explosively, shattering the rock from the inside out. It's like setting off a tiny bomb in the cliff face, over and over again. Next up is abrasion. Think of this as sandpapering on a colossal scale. Waves pick up sand, pebbles, and even boulders and hurl them against the base of cliffs. This constant scouring action grinds away at the rock, like a high-powered sand blaster. This is what carves out the distinctive notches you often see at the bottom of sea cliffs. The third tool is attrition. This doesn't directly erode the coastline, but it prepares the ammunition. As rocks and pebbles are tossed around by the waves, they smash into each other. They break down, becoming smaller, smoother, and more rounded. This process creates the very sand and shingle that the waves will then use for abrasion. Finally, there's solution or corrosion. This is a chemical attack. The salts and acids naturally present in seawater can slowly dissolve certain types of rock, like chalk and limestone. It's a much slower process, but over thousands of years, it significantly weakens coastal defenses. Now, on the other side of this battle, we have the construction crew, the process of deposition. This happens whenever the ocean runs out of energy and has to drop everything it's carrying. For deposition to happen, you first need a steady supply of material, or sediment. This sediment comes from rivers carrying silt to the sea, from the very cliffs being eroded, and from offshore deposits. The key players in building up a coast are what we call constructive waves. Unlike the violent, destructive waves of a storm, these are gentler. Their push up the beach, known as the swash, is stronger than their pull back down, the backwash. This means, with each wave, more sediment gets pushed up and left behind than is pulled away, gradually building up the beach. But how does this sediment get to the right spot? The most crucial transport system is a process called longshore drift. It's a fascinating bit of physics. Most waves don't hit the shore head-on. They arrive at an angle. So the water and sediment are pushed up the beach at an angle. But when the water flows back, gravity pulls it straight down the beach, perpendicular to the coastline. The result is a zigzag movement of every grain of sand, every pebble along the coast. This littoral drift is like a massive conveyor belt, constantly moving material down the shoreline, and it's responsible for creating some of the most amazing coastal features. So what does this constant battle between erosion and deposition actually look like? It creates a stunning gallery of natural sculptures. Let's start with the erosional landforms, found where the coast is losing ground. The most classic features are cliffs and wave-cut platforms. As waves, armed with abrasive sand and pebbles, relentlessly attack the base of a cliff, they carve out a wave-cut notch. As this notch gets deeper, the rock above it becomes unstable and eventually collapses. The cliff face crumbles, and the cliff itself effectively retreats inland. Left behind at the base is a flat, rocky surface called a wave-cut platform, which you can often see at low tide. It's the footprint of the former cliff. On coastlines with alternating bands of hard and soft rock, we see headlands and bays. The sea's erosive power easily carves away the less resistant soft rock, like clay, creating sheltered inlets or bays. The tougher, more resistant rock is left jutting out into the sea as a dramatic headland. And it's on these headlands that we witness one of nature's most incredible sequential creations: caves, arches, stacks, and stumps. It starts when waves find a weakness in the headland, like a crack or fissure. Hydraulic action and abrasion enlarge this crack into a sea cave. If the erosion continues all the way through the headland, it forms a breathtaking natural arch, but the story doesn't end there. The roof of the arch is now exposed to weathering from above and erosion from below. Eventually, it becomes unstable and collapses, leaving a tall, isolated pillar of rock known as a stack, and even the stack isn't safe. Further erosion at its base will cause it to topple, leaving behind a small, rocky outcrop called a stump, often visible only at low tide. Now let's flip to the areas where deposition is winning and new land is being born. The most common depositional landform is, of course, the beach. It's simply an accumulation of sand or shingle, but where longshore drift is in full swing, we get more complex structures. A spit is an elongated ridge of sand that stretches out from the mainland into the sea. It forms where the coastline suddenly changes direction, but the longshore drift conveyor belt keeps going, dropping its sediment in a line out into the open water. Sometimes, a spit can grow all the way across a bay, connecting to the other side. This creates a bar, trapping a body of water behind it to form a calm lagoon. Where major rivers meet the sea, they deposit vast amounts of sediment, forming deltas. If the river drops sediment faster than the sea can carry it away, new land builds up, creating fertile fan-shaped landscapes like those of the Nile or the Mississippi. For centuries, these natural processes were the only game in town. But now, there's a new player on the field: humanity. Our activities are dramatically tipping the balance, often accelerating erosion. For ages, we've tried to control the coast with what's called hard engineering. Think of massive seawalls, built to absorb wave energy. While they can protect the land directly behind them, they often cause a new problem. Waves hitting the hard, vertical wall are reflected with great force, scouring away the sand at the base of the wall and eroding the beach in front of it. Another hard engineering tool is the groin. These are the wooden or rock fences you see running out into the water at right angles to the beach. They're designed to trap sediment being carried by longshore drift, widening the beach. And they work. But by trapping that sand, they starve the beaches further down the coast, which then start to erode even faster. You've essentially just moved the problem down the road. Recognizing these issues, there's been a shift towards soft engineering, working with nature, not against it. One popular method is beach nourishment. This is exactly what it sounds like. We add huge quantities of sand to a beach to make it wider. It's more natural looking, but it's expensive and often needs to be repeated every few years as the new sand washes away. A more sustainable approach is dune restoration. Sand dunes are the coast's natural line of defense. By planting hardy vegetation like marram grass, we can stabilize existing dunes and encourage them to grow, creating a living, self-repairing barrier against storms. But in some places, the battle is unwinnable. In these cases, the answer may be managed retreat. This involves allowing the shoreline to erode in a controlled way, moving communities and infrastructure further inland. It's a tough decision, but it can create new natural habitats, like salt marshes, which then act as a natural buffer for the land behind them. Beyond these direct interventions, our other actions have consequences. Damming rivers traps sediment upstream, cutting off the supply that naturally replenishes beaches and deltas. This sediment starvation is a major cause of coastal erosion worldwide. And now, all of this is being amplified by the looming shadow of climate change. This is the great accelerator. First, we have sea level rise. As the planet warms, glaciers melt and ocean water expands. Higher sea levels mean waves can reach further inland, attacking areas that were once safe. It's like giving the ocean a permanent leg up to punch higher. Second, a warmer climate is predicted to bring more frequent and more intense storms. These superstorms generate larger, more powerful waves that can cause catastrophic erosion in just a few hours. The consequences of the shifting shoreline are profound. We see habitat loss, as beaches, dunes, and vital salt marshes are washed away. This leads to a loss of biodiversity, as countless species lose their homes. For society, the impacts are direct and costly. In the United States alone, coastal erosion causes an estimated $500 million in property loss every single year. Homes, businesses, and critical infrastructure are under threat. Tourism-dependent economies suffer as their main attraction. The beach disappears. In the most severe cases, entire communities face the heartbreaking prospect of displacement. So, what is the path forward? We can't just build walls everywhere. The future lies in a smarter, more integrated approach. This means combining hard and soft engineering where appropriate. It means championing nature-based solutions, protecting and restoring mangroves, coral reefs, and salt marshes that provide incredible natural protection. And it means having strong policies that guide where and how we build along our coasts. Our coastlines are a testament to the power of nature. For millennia, they have danced to the rhythm of erosion and deposition. But now, the tempo is quickening. Understanding the science, as we've discussed today, is the critical first step. The future of our coasts depends on our ability to shift from a mindset of controlling nature to one of working in harmony with its powerful and dynamic processes. Thanks for tuning in to Fun Facts Online.